Okay, these are solutions for the chapter 5 test. So we want to write an equation in slope-intercept form. Remember that the slope is like the m in that equation. The b is the y-intercept. So we can tell that the y-intercept here is, actually that should be 5. I don't know why I wrote 4 there. The y-intercept there is actually 5, not 4. And then the slope, you just find two nice points. If you go down 2 and over 3, you get another point. So y would be equal to negative 2/3 x plus 5, not plus 4. So you write it in slope-intercept form. You plug the slope in where the m is and the y-intercept, which should be 5, where the b is, and that's the first equation. For the second equation, the y-intercept, you can see that the y-intercept there is just above 2 units above the 2. That y-intercept is 4. So and then the slope, you just try to find another nice point. I find a couple here. And you notice how if you go up 1 and over 2, you can just keep doing as much as you want. The slope must be up 1 and over 2, or a shorter way to say that is 1/2. So the equation there is 1/2 x plus 4. So that's those two equations, slope and intercept form, except the first one, the 4 should be a 5. For the putting equations in point slope form, all you have to do is have at least a point and a slope, and you just substitute those values in. Remember that the point that you're given goes into the x1 and the y1 in that equation, and the equation is preloaded with a minus. So even though you see a minus, it's actually a positive values for that point. For the second one, notice how we have a negative x value there, but because there are subtraction signs preloaded in the equation, you're going to have like a double negative right here. So instead of leaving that double negative, it's not that it's wrong to put it, it's just that we can simplify that. So I'm going to rewrite that. Instead of saying x minus negative 2, having an x plus 2. But just substituting values in to get the point slope form equation. If we want to put an equation in standard form, this equation starts off in slope intercept form, but to get it in standard form, you got to get the x and the y on the left side. You have to have the number that has no variable on the right side. That's like what the 5 is. And we want integers, is what the instructions say. We don't want fractions. So to get rid of the fraction 3/4, I don't like the 4 there. I don't like the denominator part. So I'm going to multiply both sides of the equation by 4. That's one option. Another option could have been I could have distributed the 3/4 instead, but I just figured this option is better. So I have to multiply everything by 4. So you notice that y turns into a 4y, the 5 turns into a 20, and we prefer not to have a negative coefficient on the x, so I multiply everything by -1, and there's your equation. For this one, again, we don't want any fractions in this. We want the x and the y on the left side. And so you can choose to distribute the 1/3 to the x and the 6, but instead of doing that, you could also just multiply both sides of the equation by a 3. So if I multiply the left side of the equation by 3, I get 3y plus 12. If I multiply the right side of the equation by 3, the 3 and the 1/3 just cancel out, so you're just left with the x plus 6. To finish getting it in standard form, you need to move the x to the left, and you need to move that 12 over to the right. So subtract x on each side, but also subtract 12 on each side to get all the constants on one side, and you get negative x plus 3y equals -6. But again, we prefer not to have a negative coefficient on the x, so I just switch the sign on everything, and that's the equation in standard form. For number 7, we're graphing these equations. The first one's it's in slope-intercept form. So I'll just plot the y-intercept, which is -3. And I use the slope to go up 4, but don't forget that the denominator there is 1, so it's up 4 over 1. You could also go down 4 and left 1, like treat it as like a -4 over -1. But since we have plenty of room, just going up 4 and over 1 works fine. Just remember to first plot the y-intercept. Connect those dots as best you can. I always suggest plotting at least 3 points, but if you use your straight edge correctly, you can get away with 2 points. For this one, it's not in slope-intercept form, but I can write it in slope-intercept form. It's like the slope is 0. So the y-intercept is 7, but the fact is that all the y coordinates are going to be 7. This is a horizontal line. So you should know that anytime it's y equals a number, it's a horizontal line. That should be instinct. For this one, it's in point slope form. I can just graph it like this. I don't have to turn to slope intercept form. You can if you want, but just plot those points. Notice how in point slope form, the negative is preloaded. So the point given is not 2, 3. it's -2, -3. So I'm going to plot -2, -3. I'm going to go left 2 and down 3. And I'm just going to follow the slope rule. Up 1 over 2, up 1 over 2. Do it at least twice. I can do it 3 times to make my line really straight. And then I just graph the line as straight as I can. For number 10, it's in standard form, which is my least favorite way to graph things. But one advantage of standard form is you can plot the x and y intercepts pretty easily as long as they're whole numbers. So the x-intercept, I just divide that 15, the constant, that c, by the b, the 5 in this case, to get the y-intercept. You get the x-intercept, but divide the 15 by the a. And you can see it this way. I'm literally substituting to get the x-intercept. I'm making the y 0. To get the y-intercept, I'm making the x 0. Because that's true of both x and y intercepts, that in an x-intercept, the y is 0 and vice versa. So the x-intercept, however you do it, is -5. The y-intercept is +3. And so you can graph that using standard form and finding y-intercepts and x-intercepts. If instead you prefer to use slope-intercept form, to convert to slope-intercept form, the short answer is to just get the y by itself. That's a really good way of summarizing it. If you have y by itself, you probably have slope-intercept form. And if you put this in slope-intercept form, you'll notice that this graph matches this exactly. If I go up 3 and over 5, because my slope 3 fits, then I've got that equation. So you have a couple options there. Here I'm looking at direct variations, which is an equation where y equals kx. And the k is just simply kind of like the slope there. So I can get the y by itself, and when I write this as y equals kx or y equals something times x, there's no y-intercept. So in a direct variation, it always goes through the origin, or it has no y-intercept. So this is a direct variation, and the constant of variation, which is kind of like the slope, is -2/3. Whereas number 12, I'm going to try to get the y by itself. I'm going to try to write this as y equals something times x. But when I do that, I can get the y by itself, but the y-intercept is not going to be 0. Like, it doesn't go through the origin. You can graph it to confirm that, or you can, to see why it's not a direct variation. If I double the x in a direct variation, it should double the y. But if I choose two x coordinates and solve for their y coordinates, even though the x coordinates double, the y coordinates do not double. So this is not a direct variation, but as long as you know that it's because the y-intercept is not 0, you can just tell right away without having to show it using this table. Here I'm trying to sketch a graph of an absolute value function. Right here, you should know that the -4 inside the absolute value bracket shifts it over to the right. If you don't, you can make a table of values, but the vertex of a normal absolute value equation is through the origin 0, 0. But since this one is moved over to the right, I just shift that graph over to the right. So that's the equation of the graph that I'm asked to actually plot. If you don't understand that, you can always make a table of values. And as long as you choose enough values, it's important that you know that this is not a line. This is an absolute value function. Absolute value functions have a V-shape. Pick enough points, plot them on the grid, and you'll see that V-shape take form. And it helps to know where the vertex is. But if you plot enough points, you can find the vertex. But it's best to know the parent function and how this thing is shifted. For this one, instead of it being shifted right or left, since the +3 is outside the absolute value brackets, or the absolute value symbols, that means that it's a shift up or down, and a +3 is a shift up. So I know that this is going to have its vertex 3 units higher than a normal absolute value function. So I'm going to shift this 3 units up from where it was. I can also graph this on my calculator. So if you have a graphing calculator, you can put that in here. You have to go to second catalog to get the absolute value symbol, and you can set your window right. And here, like, the window's looks a little different than my graph because it's not squared off, and it looks a little better when you do that. So if you know all those features, you can use that. You can generate tables also using your calculator, but this is all stuff that you can do by hand. So really, using a calculator kind of slows you down, but if you know the parent function and how it shifts, that's the best way to get answer these questions. For number 15, we have a fixed cost here, and it costs us $30, and then we have an incremental rate of change, the 5, we gain $5 for every pet that we wash. Now, the fixed cost is actually not like a bonus. Like we don't get $30 and then get $5 more. It actually costs us $30 to start getting supplies. So we're going to make that 30 a negative. And you can put it in slope intercept form, or you can put the negative 30 first, then plus 5x. Both equations are actually right. But you'll notice that at 0, the y-intercept, like when x is 0, if you wash no pets, you're just in the whole $30. But as you wash a pet, you gain $5 more each time. There's no need to connect the dots here. It's technically discrete, but you can see exactly what your amounts are going to be each time you wash a pet by graphing those points. The y-intercept, which is when the x is 0, is negative 30. You can say negative 30, 0 comma negative 30, but just putting the number makes more sense. The x-intercept is 6, and that's actually the break-even point. So both of those values have meaning there. Negative 30 meaning your starting value, and the 6 is how many pets you wash to break even. For number 16, I'm going to make a scatter plot here. On the test, I'll be giving you the grid. Really, in real life, when you're doing a scatter plot, you have to choose the scale and the grid. But on the test, you'll be given the grid, and I'll choose the scale for you just for time's sake. And all you have to do is plot the points, and you're just going to roughly sketch a trend line there. So the question, there will be no question where it's like, it's not going to ask you to find based on your scatter plot what the data is going to be. Instead, I'll give you a separate question where I give you a trend line equation, and you just figure out what the values are going to be. But for here, for the scatter plot, I'm just going to roughly plot these points, and it's not going to be perfect. The only way to really do it perfect is to do it on a computer or a calculator, which I will show you how to do. But I'm just roughly plotting these points on there. And to make a trend line, if you're doing it by hand, it's not an exact science. You just kind of make a line that goes through the points. So I'm just going to highlight the word trend line yellow, and I'm just going to roughly go between these points. And it's going to kind of help me ballpark about where I can fill in the gaps of the knowledge that I don't know. So I don't know, I don't have data on 2006, but I know that the data on 2006 will be somewhere close to that trend line. So it'll be roughly 15,000, and maybe it'll be less because in 05, there were fewer people. So maybe it's a smaller number. If I want to figure out in 2015, the scale that I originally chose doesn't work. So you can see the drawback of doing scatter plots by hand is that your scale has to work for the questions that you want to ask later. So based on my trend line, it seems like it's about 6,000. But if I do this on a calculator, I put the data in there. Instead of putting the actual years, I just substitute 99 instead of 1999 and 101 instead of 2001. I go to stat plot, turn that on. And again, this is not anything that you are expected to have to do on a test. But if you really wanted to make a good scatter plot, these are the steps to do that. You put it in the stat, the list 1, list 2. You go to stat, you go to calc, you go to linreg. You got to set your window right, be able to see your values. Here I'm setting the max values to be a little further out because I want to see what it looks like in 2015. And so I'm going to set my minimum Y value all the way to 0. So in 2015, I can use either the trace key, which 2015 is actually the number 115 on my graph because of the numbers I chose. So in 2015, it's actually closer to about 3,900, whereas the trend line, if I had to guess based on the trend line I drew just by hand, I get closer to like 5,000 or 6,000. So if I use a computer, I can see that the actual predicted value is going to be closer to 3,900. For number 17, we're writing the equation that's parallel to this given equation, but it goes through this point. So I'm going to keep the slope, but I don't care about that y-intercept. So the slope originally is -1, so I'm going to keep that slope of -1. And then I'm going to throw away the y-intercept, and I'm going to use slope-intercept form. I'm just going to temporarily plug in the x and y values that I'm given into slope-intercept form, and then I can figure out the new y-intercept is +8, a +8. Now, I can also use point-slope form, so you don't have to use all 3 of these strategies, but I'm going to show you 3. If you use point-slope form, just plug the points and the slope into point-slope form, and that equation actually is a point-slope form equation. You can also say you want to end up with something that's in slope-intercept form, but you want to start off with point-slope form. Get the y by itself, and there you have the same equation that we got from the first method. You can also do this graphically. It takes a while, and it's not practical if you're dealing with like bigger numbers. But we can plot the original line. We don't really care about the original line. We only care about its slope. Since we only care about its slope, we're going to make the new line have the same slope. And actually, I graphed that line wrong. So I'm going to regraph that. Y-intercept of +1, and the slope is -1, and did it backwards the other way. So that's the original line that's given. But I only care about the slope of that line. So I'm going to make another line that goes to the point 4, 4, which is plotted with that black dot. And if I have a slope of -1, if I trace it back to the y-axis, it has a y-intercept still of +8, which I got that y-intercept doing all three methods. For number 18, when we're dealing with perpendicular lines, again, we still keep the slope, but we make one little change. Perpendicular lines have opposite reciprocal slopes. So if the slope was 2/3, the perpendicular line would have a slope of -3/2. Here the slope is -1/1, so my slope that I should be using is +1/1. When you flip a 1, it doesn't actually look like it flipped. So I didn't just make this the opposite sign. And let me actually re-edit here. I forgot to make it a +1 at all. So I make the slope +1 there. And when I solve for the y-intercept, I get that the y-intercept is 6. So again, I'm taking the opposite reciprocal of the slope to get the new slope that I want. I'm not using the y-intercept of that equation at all. And I'm plugging the point into either point slope form or slope intercept form to figure out what the equation of my new line is. Here's my equation in point slope form using point slope formula. If I want, I can take that equation and put it in slope intercept form from that if I'd like to. I can also graph this equation and solve it that way. When you're dealing with small numbers, it's okay to use a graph to do it. First, you plot your point, but here's the idea. I know that my slope given was -1, so the perpendicular slope is going to be +1 because I opposite reciprocal that thing, and I still get the y-intercept of 6. This question is asking about scatter plots. It's just asking, do you understand how they relate to trend lines? So scatter plots and trend lines and line of best fit just help us approximate and predict and fill in the gaps of what we want to know about data and scatter plots. For our number 20, I want to write an equation that's parallel to the graph of y equals 0.5x minus 10, and just write some equation that is parallel to that. All I have to do is pick a different y-intercept. That y-intercept could be 5, -3, or 17. Either of those work. There are infinitely many other answers that work as well. For number 21, this is just asking, do you know the difference between how direct variations relate to linear equations? They are linear equations. They simply just have a y-intercept of 0. So the direct variation, as long as it goes through the origin, either that blue line, that green line, the other green line, those are all direct variations. 22, correlation coefficients. And this deals with scatter plots and lines of best fit. I'm going to look at the correlation coefficient of the one I did. If the correlation coefficient is close to 1, all it means is that the data is represented very well using that equation. So I know that if it's close to 1 in the case that I did, it's close to -1 because it has a negative correlation. But if your data is really spread out, your correlation coefficient is going to be a lot less than 1, like maybe 0.7 or maybe even lower if your data is really spread out. If your data has like a downward slope, but the points are close together, then you're going to have a correlation coefficient pretty close to -1. If your data is super, super spread out, your correlation coefficient is going to be really bad. It's going to be really close to 0. So that's what the correlation coefficient says. 23. I'm saying if I can draw a line, how many lines can I draw that go through this point but are parallel to the line? The answer is there is only one. Because the parallel lines have to have the same slope. So if I gave a different point, if I plotted, say, I put a point in a different spot right here, this blue point, then there's only one parallel line that goes through there. The green point, same thing. There's only one line that goes through. Those are the answers for the Chapter 5 test. And